All right, this next project is John the Ripper. I'm going to walk through using it. But first, I made a new presentation today. We're going to talk about this here for a second. And, all right. Come on, open up, Mr. Pyle. Okay. There's something called salt. You all know what salt is. Okay. We have a couple of different definitions. It's a white crystalline substance that gives seawater its characteristic taste, or basically seasons our food. Easy enough. Or when it comes to cryptography, it's a way of screwing up dictionary tags. Okay. Do y'all know what a dictionary tag is? We basically look for the word in the dictionary, hash it. The way the whole process works, I just logged into my system. My password is not stored in clear text. What happens is when I created my account or changed my password, it at that point hashes what I enter for the password and stores that. Then every subsequent login, when I go to log in, I give it my username and password, it hashes it with the same algorithm and then just as a comparison. Easy enough. That way if you were to break into Active Directory or somehow get it, you're only getting the hash. You're not actually getting the clear password. Okay. But the problem is the word potato hashed 5,000 times with the same algorithm is going to be the same hash. So you can make what's called rainbow tables. You can literally sit there. When I took a guidance software class, this guy had a 1 terabyte rainbow table. It hashed every possibility of every number, letter, and character up to 12 characters. Basically, every combination of number and letter you can think of, all the way up from length 1 to length 12, he had already done. Because what's good about that is, so we're going to mess with John the Ripper today. Rather than John having to take the password, run it through the algorithm, and then do a comparison, we're literally just doing comparison. It's just, you know, it's a million times faster. But the problem is everything's already been broken, which I'm actually going to show you a location here in a minute where you can actually check. What Assault does is it appends, or actually prepends, some random characters to the beginning of the password. So potato, now we're going to hash it with rose, for roast day. We're going to hash it with the word rose plus potato, hash those together. So now if you have a rainbow table of potato, it's not going to match rose potato. Easy enough. Then what we're going to do is we're going to store the hash of the password and the salt. So later on when I want to compare, so you know Patrick here is logging in, he types in the new, you know, his hash, which is, but then what we do is we retrieve the salt and the hash, take what he just entered, add it with the salt, and they should match. So in other words, potato can have a million different varieties this way. Understand? Okay. So walk through a little bit demo here. So if I used MD5 and I hashed the word Roy, I would get that hash. Okay? I could do it a million times, and no matter what, without salt, that is the hash for Roy. So I'm going to go to this website here, which you guys can play with if you like. The odds of you finding any of this homework on there are -0. It's even worse than 0. Okay, so I'm going to go in here and I'm going to type in this. I want this right here. Can I get it? Okay, I'm going to have to, hold on. I'm going to have to go and copy this. Nope, I need this. Okay, I'm going to copy this. I'm going to go back to this website. I'm going to put this hash in here. Now, if it was already been looked up, it should show me the reverse of it instantly. And it did. What it is, this is a large rainbow table. It knows that ROY is this hash. So it can very easily reverse that. Y'all get that? Why did it know that? Because I got it there today. Okay? Now, let's look at another. Let's continue on with the example. So, Roy equals that. You saw that it equals that. Okay? Now, let's move on. Next slide. I don't want to go to the other screen. So now if we add salt So if Rose was added to Roy, we get a different hash totally. So now if I take this hash, go back to that website, and say, okay, now reverse this hash, it's going to be like, nope, it's not in there. Okay? No reverse string was found. In other words, they do not have an entry, even though the password is still Roy. Now I added the salt or Rose at the beginning. So it still hashed Roy, but it actually put Rose and Roy together, so it was Rose Roy, then hashed that value. So what I would do is I would store Rose as the salt and the hashed value of the combination. Everybody understand that? Easy enough to do? So then when Roy goes to log in now, he's going to type in Roy. So I'm going to query Active Directory and say, okay, for the account Roy, what was the salt? So the Active Directory is going to return Rose. So then I'm going to take, whatever Roy types in as his password, and Rose, put those together, hash them, then it should match what's stored. Easy enough, and it actually works very well. So we now have many combinations. So now, if I change the salt to state, obviously it gets something totally different. So, you see, the whole point of a hash is it should always be different. Okay? And you can very easily go up on this website and create your own hashes. I'm going to go here, and I'm going to type a string. Type Patrick. Actually, yeah, let's just do Patrick. Okay? There it is. So now the MD5 hash of Patrick is this right here. Now it's stored because it created it for me, so now it's keeping track of it. So now if I go back to this website and I put that right in here and do reverse, it's going to say, oh, I know it, that's Patrick. So for anyone in the world, if their password is literally just Patrick, now this website knows it. Yes?
So for a large system that has like many thousands of people's passwords, would it use the same salt for all of them? Or
no, actually, a proper salt should be the length of the hash. Should be very long, and it should be randomly generated for every time an account is created or a password is changed. So we're creating Patrick's account today. We randomly generate this very long salt along with the password that he picks. We store the salt and store the hash of the two put together. If he changes his password, we generate a brand new salt. So we're actually storing two components. And we're actually storing the salt in clear text. Yes.
But assuming the website or whatever didn't have a feature to stop you from putting in 50 billion password attempts, you could still reinforce it.
Yes, we could. But since this hash is now randomly generated that long, I mean, what's it, 512, 256, however many bit this is. See, for your assignment, the salt is just a few characters. So you could try them all. I mean, if the salt was one character, yeah, I mean, we were going to check the 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, A through Z, and then Z. But every time you add another length to it, it gets long. So the salt for a secure system should be very long. So now that word potato now has, rather than one entry in a rainbow table, now could we theoretically create a rainbow table that stored every combination? Oh yes, most definitely. What if we use ASCII values only? Well, it's 95 characters, so, well, there's so many hundreds of thousands of entries. But still, that's a usable number.
Well, that only works if you're going after the hashes and not going through the actual interface that provides the salt.
Well, it really depends. Okay? An FTP server, for instance, it could care less how many times you try. It doesn't lock out after 3 tries. It really depends on what the system is. And the funny thing with FTP version, whatever, years ago, if you hit it with 4,000 simultaneous connections, it literally gives up and lets you in. So yeah, I mean, it's been fixed. But what's the latest issue on the iPhone? Did y'all hear the latest issue? You set the date to what? Like January 1st, 1970 at 1 p.m. instantly locks your phone up.
To epoch time.
Yeah. So what's cool is people, if they want a new phone, they set it to that day. It literally locks it. You walk in, Apple, my phone's totally dead to give you a brand new phone because there's no fix for it. So Apple says, yes, we are aware of this. We are working to fix the problem. But just think about it. Hey, my phone's almost out of warranty.
My question is who decided to try just to set it to each
What? There was a guy recently found that if you hit this thing 23 times, it's like, who's going to hit enter 23 times?
On the password, we made a certain length. And,
Yeah. It's stupid.
Wasn't there a vulnerability in Android a while back where if you just typed like the longest possible password at the login screen, then it would just let you in?
I wouldn't doubt it. I wouldn't doubt it.
My phone used to have the ability to, like, if you took a bunch of pictures on your camera, because you could get to your camera through the lock
Right,
screen,
yeah,
you would eventually be able to get into the phone.
But who tries this? Obviously, somebody sat there. Let me try. Say it about time. Oh, there goes.
Let me take like 47 photos. Oh wow, look.
What gets me though is that salting's been around forever, and a lot of the breaches that have happened in the last couple of years, they just didn't even salt them.
You know, I was at Taco Bueno yesterday eating dinner, and they got the new credit card thing. You know, you just put your card in for the chip rather than the swipe.
EMV or
Yeah, and I said, oh, she goes, no. Because we've actually had this for 3 years. They haven't implemented it yet. And after October 1st of last year, if Taco Bueno had an incident, guess how much they're liable for? 100% of it now. Visa and MasterCard wiped their hands clean. What they're saying is if someone uses a swipe after October 1st, they're no longer responsible. Now, if I go with a card that doesn't have a chip, they're still responsible.
It's not only that, it's if the card implements the pins and the vendor, the retailers don't.
Right.
Whoever's got the lowest level of security is 100%.
Yeah, stupid. Yeah. So, all right. So far, so good. There's a website here, really good website. Can I go to, maybe not. Let me copy. Okay, I'm going to go to this website. And this presentation's up there. Excellent website. You can read all about how it works. It's amazingly short, but amazingly informative. And one of the things he talks about at the end, what should you do is, first of all, generate a long random salt. So using the word rows is not a good choice. Okay? Prepend the salt to the password, then combine the both. Hash the both. Store the salt in the hash. We know that. The hash, then compare the stored salt and see if it's the same one. So it's pretty easy to do to verify that the salt's correct. So, okay. Salt's awesome. A lot of systems implement it now. Not all. Okay, a lot of systems do. And we will be using salt in your homework. So, all right.
Are they all going to be the same?
What?
Are they all going to be the same?
Oh, no. They're different on each one. Okay, there's the end of the salt presentation.